This is the solution to the problem titled Cuevita. It's a projectile motion problem for a soccer ball that was hit just a bit too hard so that it barely missed the goal. We need to calculate the initial speed of this projectile. The problem says that the ball touches the upper edge of the crossbar, which has a vertical width of 4 inches. We also know that the height of the lower edge of the crossbar is 2.44 meters. Therefore, the height of the soccer ball just missing the goal is 2.44 plus 4 inches. Using conversion factors, we find that 4 inches is 0.1016 meters, and the diameter of the ball, 27.50 centimeters, is 0.2750 meters. The height of the ball is then 2.44 plus 0.1016 meters, which is 2.5416 meters. The problem also tells us that the horizontal distance to the goal is 10.97 meters, which in this context happens to be the horizontal displacement of the projectile ball. After looking at our equation sheet, we might realize that the formulas for displacement could be helpful here. The reason these formulas look appealing is because we know the displacements already, and the thing that we want to solve for is kind of hidden in the v0 variables. Notice that we do know what the value of t is here because the problem tells us that the ball reaches the goal in 0.25 seconds. So after substituting all our knowns, we have two formulas now. Notice that we also replaced v0x with v0 cosine of theta and v0y with v0 sine of theta. The v0 now is the thing we're after, but we also have the launch angle theta in those formulas, so we can't really solve for any of them yet. Whenever we're in a situation like this, when we have more than one unknown in our formulas, v0 and theta in this case, using one formula alone will not work. We need to get rid of one of the unknowns somehow. If we isolate the v0 term from the first formula, we end up with v0 equals 10.97 over 0.25 cosine of theta. We haven't actually calculated the value of v0, but we do have it as a function of the launch angle theta. So perhaps if we substitute this equation into the other formula, we can figure out a way of getting rid of theta. The formula we have now has sine of theta in the numerator and cosine of theta in the denominator. It turns out that according to a very important trigonometric identity, that ratio of sine to cosine is in fact the tangent of the angle. So we can rewrite that formula, but with the sine of theta over cosine of theta replaced by the tangent of theta. The formula looks a little intimidating, but it's actually solvable, meaning we can manipulate the numbers and the units to find out what the angle theta is. I think it would be great if you take a few minutes to find out how to calculate that launch angle theta from this formula. Make sure that your calculator is set to degrees because you'll have to do an inverse tangent calculation here. That way, we'll be sure that the answer is in degrees and not in radians, for example. So, pause the video and continue watching when you're done. Alright then, here's the answer and the step-by-step algebra involved. The launch angle is about 14.6 degrees. Finally, now that we know the angle, we can go back to one of those formulas from before, the one which had both v0 and theta in it. Here we can substitute the value of theta we just got and then calculate v0. The final answer for the initial speed of this projectile is 45.33 meters per second after taking into account the fact that all input variables were given with 4 sig figs. Moving on to part B, the problem now wants us to calculate an initial speed that would have allowed this goal to be scored. So we want the ball to end up not just above the crossbar, but just below it. In fact, this time we need the upper part of the ball to barely touch the lower edge of the crossbar. So that means the vertical displacement for this projectile should be 2.44 meters minus 27.5 centimeters, which is 2.165 meters. Other than that, all the other variables are the same. Horizontal displacement is still 10.97 meters, and the time from kick to goal is 0.25 seconds as given in the problem statement. So you could follow the exact same process to calculate a new launch angle first and then a new initial velocity, just like we did before for the no goal case. Take a few minutes to do that and then continue watching to check your final answers. Alright then, in order to score a goal, the angle must have been about 12.7 degrees and the initial speed 44.98 meters per second. This answer makes sense because the launch angle is a little bit lower, so the projectile won't go as high, and also the initial speed itself is lower. That said, it's kind of sad for me to realize that all we needed was for this player to reduce his kick force by a little less than 1%. Just a tiny 0.35 meters per second slower, and he would have made it. Oh well.